Hey everyone, in this video I'm going to go over the quad on NADH. Now I know you have two of these images on your page. However, we're only going to start with one of these for the first part of our cellular respiration lesson. So let's get started. First of all, you'll notice that on the y-axis here, you've got relative energy content of molecules, starting with here at the bottom is low, going upwards towards the high. So what it's trying to show you is that anytime we have molecules at this level right here, they would be considered high energy. And then anytime we have molecules at this level right here, they would be considered low energy. So we're going to go through the process of how NADH helps in cellular respiration by taking electrons away from high energy molecules and eventually making a low energy product or a lower energy product at the end. Remember that when we're talking about energy, we're talking about the energy, chemical potential energy, which is the energy that's stored in the bonds of these molecules. Also remember that when we talk about this gain or loss of electrons, we're talking about oxidation and reduction. So we can't have oxidation without reduction. And in the case of NADH, as y'all saw in the video, not only is the NAD plus going to gain the electron, it's also going to gain a hydrogen atom as well. So in cell respiration, our starting molecule is glucose. And glucose is broken down, in other words, this is the catabolic process, overall catabolic process, into an end product that is called pyruvate. So this is simply a biochemical pathway, meaning that there's an enzyme that acts upon the substrate glucose that makes a product. The product then makes the next product, and the product becomes the substrate for the next enzyme. The product becomes the substrate for the next enzyme. The product becomes the substrate for the next enzyme, so on until ultimately we get pyruvate as that end product. And in the process of converting the substrate glucose into the very final product, pyruvate, glucose, or at least the intermediates in between these, are going to get oxidized, meaning they're going to lose electrons. Now, if the glucose is getting oxidized, something else must be reduced. In this case, the coenzyme NAD plus is what is going to get reduced. And so what you see here is this electron is going to transfer to this NAD plus along with the hydrogen, because it has the two active sites, or the two binding sites. The electron is then going to join with this NAD plus and make NADH. Now, think of this like a cog in a wheel system. So we want to keep this process turning because this is where we're going to make ATP. But in order for this wheel to turn, this one needs to help out. We always need to have something to take those electrons away. In other words, we're always going to need that NAD plus to come and grab electrons. But once it's converted to, once it's reduced, the NAD plus is reduced to NADH, it can't take on any more electrons. So it's going to have to get rid of that electron that it picked up to go back to NAD plus, so that NAD plus can come and pick up more electrons from the continuing supply of glucose. So as you continuously eat, you will have more glucose coming in and more electrons that need to get stripped, which means we always need to have a supply of NAD plus available. But again, once that NAD plus is reduced to NADH with this electron, so there's the electron, this is now reduced, then the NADH needs to be oxidized back to NAD plus, meaning that it must lose the electron that it gained in this part of cellular respiration. So in this case, what's going to happen is that electron is going to be donated to what we call the final electron acceptor in this part of cellular respiration. And in this part of cellular respiration, our final electron acceptor is going to be oxygen. So the electron is reduced, the oxygen is reduced. The oxygen is going to gain the electron as well as hydrogen that's floating around in the cell, and it's going to form the final product, which is water. So there you have it. This is the role of NADH in At this point, aerobic respiration is all we're covering for this top part. But you can see that its job is to kind of go between being reduced to NADH and oxidized back to NAD plus, so that this wheel over here can keep turning. Without this wheel turning, there would be no ATP production, and that would mean death. So there always has to be something that's going to gain the electrons from here. In other words, it's going to be reduced. And then once it's in its reduced form, it's got to give up the electron to something else so that it can go back to work over here. And so in the case of aerobic cellular respiration, this is the final electron acceptor is going to be oxygen producing the water. And that's what aerobic respiration means. It means that your final electron acceptor is oxygen.